All right, we have made it to the attributes chapter. Now, up until this point, we've kind of tiptoed around what attributes are in order to keep things simple for us. But now it's time to get friendly with them and learn what they're all about. So, in my opinion, attributes are the single most important concept to understand in Houdini. So, what exactly are they? Well, I think that to make a really simple comparison to Cinema 4D, attributes are really a lot like vertex maps or weight maps. They allow us to attach data onto our points and our primitives and carry them along through our network. I think like if nodes represent the skeletal structure of a Houdini project, then attributes are the lifeblood that are, carry the lifeblood or like the nervous system that's carrying information and data throughout our networks. They represent our geometry, and they're being carried and modified from node to node as we propagate through our networks. And they drive everything from point positions to point normals to point scales and anything you can possibly imagine. Even in dynamics networks, they're representing velocities and temperatures and all sorts of things. And so we can use all sorts of nodes inside of Houdini to create and modify and destroy attributes as we need them, and as we need to push information through our networks in order to control our simulations or our creations in general. So with that being said, I think like at this point what I'd like to do is just sort of do a little bit of an overview of how attributes work, how we can create them, how we can manipulate them in sort of a simple sense. And then we'll dive into a little bit more of a complicated example or more of an applicable example in the next section. So for right now, the first thing I want to do before I do anything is I want to bring up our attribute spreadsheet. I know you're probably thinking, oh no, it's a spreadsheet. What? So if I just, because I want to be able to see my view here and work in the spreadsheet at the same time, I could go to my geometry spreadsheet right here. But I'm actually going to just split my view top and bottom. So let's just go up to the corner here. I'm going to say split pane top bottom. And over here where it says scene view, I'm going to right click and choose the geometry spreadsheet. So a geometry spreadsheet. When I first saw this, I was kind of like, oh dear, what is this all about? I was not that into it at first, but you'll find that as you learn to work with Houdini, this thing will become your best friend. It will give you so many insights into what it is that you're actually doing. It is very handy. So for right now, we're just going to see how it displays information and how that is relevant to what we're doing. So the first thing I'm going to do is throw down a point. So we need a geometry node. I'm going to create a geometry node. I'm going to dive inside that. I'm just going to throw down an add SOP. In that add SOP, I'm going to just turn on this first point. You can see that it creates a point here at the origin. I'm just going to hit the D key on my end and make it a little bit easier to see to see our points. So under geometry, I'm just going to scale up the point size like so. And here you can see that we've got a point. And what has happened is it is created and it is displaying for us our position attributes. By default in Houdini, position is represented by this P. And you can see it's got a P of X, Y, and Z. And right now, because this point is resting at the origin of our scene, these values are all equated to 0. Another way we can kind of briefly preview our attributes is by middle mouse clicking on this node or any node. And you can see here that it is telling us we've got one point attribute. It says it's a P, and it's indicating that it is 3 floats, which is a vector. What other types of, let's just, for the sake of adding some attributes to this, let's add color. So I'm going to throw in a color node and just wire this in, and let's just set it to something different like blue or red. That's kind of obvious. So now we've got our node is our point is red rather. And you can see now in our attribute spreadsheet, we have a new set of 3 attributes here, which is CD of R, G, and B for red, green, and blue values. And you can see that because we set our value to red, really we just have, looks like 0.9 in the red and the rest are 0. If I go and change this to something like blue, you can see that it changes. Now blue is the value that has 0.9 in it, and the other ones are 0. And so this is just a mixture of whatever colors it is that, you know, a mixture of whatever red, green, and blue values make up your color. So yeah, CD happens to be the common name for color in Houdini. Now there are, like P and CD, there are many predefined attributes in Houdini that are like this, that Houdini will put to use if it understands the names that you're giving it. So like P and CD, Houdini has many common attributes that it recognizes that if you were to, you know, say supply an attribute and define it, it will recognize and put those attributes into good use. For example, P scale for particle scale is one that is recognized by Houdini. Alpha is recognized by Houdini. Velocity is recognized by Houdini. If you supply these attributes to your points, these specific ones, Houdini will know what to do with them by default. So knowing what all these attributes are sort of comes with, you know, time. In time, you'll memorize them. You'll memorize the ones that are important to your workflow. It's just important for now not to get overwhelmed with the fact that they exist, and just learn as you can which ones work to help you achieve whatever it is that you're trying to achieve in your scene. So let's just explore another way we could have gone about creating color on this point. We used the color node, which basically allows you to, you know, just pick a point color. I could do this using an attribute create node. This is pretty much more, I mean, while color is a very specific node for creating color, an attribute create node is much more generalized for creating pretty much any type of attribute. So if I wire this in here, to do the same thing, like create a red point using the attribute create, if I highlight this, you see our color goes away, and it's simply creating an attribute called attribute1 that's appearing over here in our geometry spreadsheet. Right now, it's what we really want is we actually want a vector attribute, and we want to name this attribute. Well, if I change this to 1, 0, 0, you can see this first value is 1, representing the first point of the first entry of the vector, and then there's these other 2 points, and then there's a fourth one, which we won't really be using. So these first 3 fields represent the different values of this vector attribute that we're attaching to our point. Now, if we look down here in our attribute spreadsheet, you can see that we have an attribute of 1, 0, and 0, but it isn't doing anything because it's not named appropriately. Now, if I go and change this to CD, Houdini automatically, like I was saying, knows what to do with the attribute CD. It's a common attribute that is sort of built in. And so now it is taking the red value and setting it to 1 and setting the green and blue values to 0. So now you can see that in our previous example, it said CD of R, G, and B. Right now, it's defaulting to X, Y, and Z. RGB and X, Y, Z are sort of interchangeable ways of accessing which component of a vector we're looking at. So a vector attribute is an attribute that has 3 components to it like this. For example, position in X, Y, and Z space, or color in red, green, and blue space. These are really what vectors are. It's just 3 values that are stored as floats. You can see right here, it's a 3 float vector. And it's storing that information in sort of a little component like that. So we've got our position attribute here, and we've got our color attribute here. And these are both vector attributes. Now, we don't have to use vector attributes. Vectors are just one type of attribute that just happen to have 3 components to them. Other examples of this would be like a normal. A normal would be a direction pointing away from our point, or velocity is also a vector. But sometimes it's important or valuable to have other types of attributes that aren't vectors. So what other types of attributes do we have? If we look under this menu, you can see we've got float attributes. Float attributes are really what each one of these are individually. A float attribute basically is a number with a decimal after it, and an integer value is a number that is just a whole number. It can't have a decimal. Numbers like 1, 2, 3, where, you know, floats are really like, can be like 1.1, you know, 1.14 or 2.9, something like that. And then after that, we've got the vector attribute. Then we have string attributes. String attributes are anything like a name where it's using a text field. So we could have piece 1, piece 2, you know, something like that has words involved with it or anything like that. Then we've got float arrays, integer arrays, and string arrays. And those are basically lists of these attributes, which we're not going to really be concerned with just yet. Let's create a float attribute to accompany our CD attribute here. So I'm just going to throw down another attribute create. And here I'm just going to call this one, I'm just going to rename this called create color attrib. And this one I'm going to say create scale. Actually, I'll call it create p-scale, because p-scale is actually the common name in Houdini for the scale of a particle. So if I go up here and name this p-scale and set its value to 0.5, you can see that nothing actually happens to our point. But we do have a p-scale value that has been added here. Notice how there's only one column here. It's just p-scale set to our value that we set over here. Now, if I middle mouse click over here, you can see we've got our CD, our color, our position, and our p-scale, which is just a float. So we've got 3 floats for each of our vectors, and then just float for our p-scale attribute. So likewise, if I go here and I'm just scaling this attribute of this p-scale up and down, nothing is happening to our point. Now, why is that? Well, the thing is mathematically speaking, a point is just a simple location in 3D space. There's no scale to it whatsoever. It's actually 0-dimensional. It's literally just a location. It's infinitely small. But with the power of attributes, we've actually attached an instruction to it that says, hey, I have extra information. So leading me into another scenario with, you know, and like further on down in our network, we could feed this to some object to allow it to understand what size this particle represents, like in a particle network or something like that. So that's sort of the beauty, is mathematically this thing should have no understanding of what scale even is, but yet it does, because we were able to attach an attribute onto it. So let's just, to demonstrate how this attribute can be used downstream, we're just going to copy a sphere onto this point. So I'm going to throw down a copy to points, and I'm going to throw down a sphere. And if you look at the copy to points, you know, we're gonna wire in our sphere on the left. These are the primitives we want to copy, and then these are the target points we want to copy onto. So I'm just going to highlight this. You can see we get this sphere that has appeared where our point was. Now there's a sphere. If I look up here, you can see that what the defaults are is that it's going to transform our incoming geometry using point orientations. Really, that's sort of a short sentence. If you hover over and see, you can see it rotates copies to face the target. Point normals also applies translations, rotations, and scales according to the translate, rotate, and scale point attributes on the template points. Because our template point has a p-scale attribute, it is changing the scale of the sphere to be whatever this attribute is. So if I now scale this attribute that we created on the attribute create node, you can see that it's changing the scale of our sphere. Oops. I'm going to put that back to 0.5 and zoom in on it. So that's one example of how attributes are powerful when being used on stream. I know that this example is pretty simple, but it should, in time, when you learn how to build upon these attributes and transfer them around throughout your scene, you can generate some pretty awesome behavior. Let's look at another example here. I'm just going to throw it on a grid. And then on this grid, I'm going to throw it on an attribute randomize. Attribute randomize is another node just like the attribute create. In this example, it's actually going to be randomizing the color of our points on the grid. So if I wire the grid in and highlight our attribute randomize, you can see that we get this sort of rainbow colored stuff going on. And really what that is it's showing us that each one of these points has its own individual color. And then you get this weird gradient going on in the middle because across the face of each primitive, it's sort of interpolating between those colors. So for example, if this point right here is blue and this one's this sort of tan color, it's going to create this gradient going from blue to tan along this axis and so on and so forth throughout the entire thing. This is basically, you know, like a vertex map at this point. You know, if you're mapping point color, that's exactly what this is. So let's just talk really quickly about attribute class. So far, we've been working with point attributes. All these attributes exist on our points, but we could also up here put attributes on vertexes, put them on primitives, and put them even on detail, which is just basically on our entire geometry as a whole, have it carry its own singular attribute. So if I go over here to my attribute randomize and say change my class from points to primitives, now it's choosing a random color for each single primitive. So now if you look down here in our attribute spreadsheet, our points attribute for color has gone away. But if I switch over to my primitives tab, you can see that there they are. It has moved the color attribute onto the primitives themselves. And that's why we don't get any of this interpolation anymore, is because the attribute of color is not being stored on the corner points anymore. It's actually being stored on the primitive face itself. So in another example, I'm going to just throw down a grid, and I'm going to just increase the rows and columns to like 50 by 50. And then let's also throw down a sphere. Oops, I accidentally made a copy of this grid. Just going to delete that. I'm going to throw down a sphere. And before I do anything, I'm going to copy this sphere onto this grid in a second. But I want to just, you know, show the paint node. So, you know, I could, you know, if I wanted to paint the weight of an attribute, I could do that. So let's do that. So here I've got a paint node. I'm going to wire in the grid and highlight the paint node. And then if I go and select my manipulator over here, you can see I get a little brush. And then I get this tooltip at the bottom. It says left mouse for foreground color, middle for background color, and shift left drag to change the brush radius. So if I hold down shift and left drag, I can make my radius bigger or smaller. And I could go over to my background color tab. I got my foreground, my background. My background tab, I'm just going to hit apply to all. So I get a big black square now. And then if I go to my foreground color, I can start painting on that. So you can see I'm painting these color attributes. And if we scroll around in the list enough, you can see that those values are changing. And if I'm painting over this, it's constantly updating down here. So I'm going to just change this a little bit. I'm going to go back to my paint node and go to the background color and just clear that off by selecting apply to all. And back to my foreground color, I'm going to go to my brush tab. I'm just going to change the opacity of my brush to something like maybe 0.05, something that comes on a little bit more gradual, something like that. In fact, I think I might undo that and go back to maybe even 0.01, something even more gradual, so I can actually build up color on this as I paint. Cool. So if I now decide to copy my sphere onto this, you can see that because we have copy to points has these copying point attributes selected, you can see that when I copy this, that some of my spheres are starting to appear to be white and some of them are black. That's because they're inheriting the color of their point attributes that they're being cloned onto. So what if I wanted to use this color now to drive the scale of my particles? I mean, I could just create a p scale attribute and set it however I want to, but the cool thing to note at this point is that now that we have a color attribute, we can use it to drive another attribute that Houdini will see and use to make a determination about what it should be doing with this geometry. So let's throw down a attribute create node. And we're just going to create p-scale again. So I'm going to write p-scale up here. And you'll see all the spheres are going to disappear because the p-scale is set to a value of 0 right now. Now, if I were to, let me just turn off my grid for a second. If I were to change the value of this, you can see my spheres are growing and shrinking accordingly. But if I wanted to use the color value to drive this, I could say, well, because I know my colors, if I just hit my color, the top of my red color here, you can see that it sorts by that color. So the largest red color is 0.35. And because we're only working with black and white values, with pure white being 111 on this scale and pure black being 000, all of my red, green, and blue values are going to be equal to one another. And you can see that our top red value here is 0.35516, and same with G and same with B. So I could take one of these components out of my color value and plug it into p-scale. So p-scale is set to 0 now, but if I go up here, because I know that I've got an incoming color attribute from our paint node above it feeding in here, I can take CD and plug it in. So let's grab, much how we wrote at frame in earlier examples, we can type in at CD, and then we just want to get the first component. So that would be .r. So you use dot to access components of your vector attributes if they exist and you want to use them. So if I hit enter now, you can see that these spheres are scaling up based off of their red value. And you can see that in our spreadsheet down here, it is simply just copied CDR over to p-scale for all of these values. So now if I go back up to my paint node, I can just sit here and paint in, I could paint in the scale of these spheres if I wanted to, and create almost like a little forest of spheres. Something like that. It's kind of fun. So speaking of like a forest, let's try and expand this even a little bit more. So I'm going to just swap out my sphere. Instead of using a sphere, I'm going to throw down an L system. So let's do that. Hit tab and start typing L system. And an L system by default is this. It looks like a little tree. Now we're not really going to get into how to build L systems, but it's just important to know that they're here. We can kind of randomize them a little bit. I could go to change my step size and give it like a number of, let me see if I have number of generations. If I crank this up to higher values, you can see that it just grows our tree into more and more complex branching like that. Kind of fun to play with. I'll just leave it at something like 8 for right now. That's cool. And maybe in my step size, I'll just increase it just a little bit. So now if I was to plug my L system into my copy to points, you'll see that all my trees are kind of laid down on their sides. Which, let me just go back to the L system real quick here and hit spacebar F to frame it up. Yeah. Just going to bring back the random scale a little bit so that I want the trunk to be a little bit longer. Let's just change this step size value to be a little bit higher. Something like 0.15 works. And on the random scale, I got about 0.54, something like that. Okay, so now when I go back to my copy to points, you can see that they're all sort of resting on their side. And this is because sometimes Houdini's actually, when it's using copy to points, it's expecting all the geometry to be oriented along the z-axis. So if I throw down a transform here after the L system and just highlight that, and I if I just highlight my copy to points, grab my L system and start rotating it so that it's pointing down the Z-axis, you can see that the trees start facing upward. It's kind of weird, I know, but it's just one of those things that you get used to after dealing with Houdini for a while, and that's just something that you want to do. So cool. Now that we've got a bunch of trees, let's just make them look a little bit more random so they aren't sort of, you know, just distributed in this sort of grid-like pattern. So now what I'm going to do is, after my P-scale attribute here, which you can see I've been painting on this grid, the P-scale attribute here, we can actually throw down a scatter, and the scatter by default is going to inherit these attributes. So if I've got my scatter here, you can see I've scattered 1,000 points, and it has also inherited those attributes and colors and P-scale values from the underlying from the underlying primitives where they're laying. So now if I show copy to points, you can see all of our trees are sort of, you know, scattered about in more of a random way. I'm going to change the relaxation iterations to I'm just going to turn them off because relaxation tries to evenly space these out. I'm just going to turn that off. So now we get a really much more random distribution. And it looks like, for whatever reason, it's probably because normal's not being defined on our scatter. It looks like our trees are now back on their side. So if I turn this off, they're now facing upwards. But what if I wanted to give these trees sort of a random rotation? Because if you look from above, they're all sort of facing in the same direction. Well, I could just, if I go up here to my attribute create, where I create my P-scale attribute, I could create another attribute using this node. So see how here we've got this attribute create for our P-scale. I can hit this plus button right to the left of it, and I've got a new attribute that I can create. Here, I could create a normal, and I know that I want my normal just pointing upward. So if I just I've got a normal, I want to add it to my points, and it's going to be a vector attribute because normals are vector attributes. You can see down here it creates the N attribute in our spreadsheet, and we want the value to be pointing in the positive Y. So I'm going to go to this second value here and put a 1 in here. And you can see that it brought our color back because it was trying to do shading based off of a normal of 0, which doesn't really make sense. So now if I turn on my normal visualizer by hitting this button, you can see I've got a bunch of normals that are facing in the upward direction. So now if I turn on my copy to points, everything's laying back on its side because it's expecting to have everything down the Z-axis. So I'm going to re-enable my transform here. And now everything's pointing back upward. But now they're not rotated. So with the combination of a normal and an up vector, we can get them to rotate randomly. So it's just as simple as this. I'm going to throw down another attribute randomize. And up is another one of those vectors that's recognized by Houdini. So if I were to go into my attribute name and type up and go up to the top here, you can see that some of these trees are pointed in different directions. Just to make it a little bit more obvious, I'm going to throw down a box for a second just so that we can see that. So these are our boxes. And if I turn off normals, so these are our boxes kind of oriented randomly. Before we put in our up attribute, all the boxes were aligned like so. Now with our up attribute that we randomized over here, they're kind of rotated in all sorts of different directions. So now I can let's just wire in instead. I'm going to wire in these trees, the L system, and here we are. So now if I go back over to my paint node, I can just, it looked like I had a lot more grid here that I wasn't seeing. I'm going to hit the D key and change the background to gray so I can see what I'm doing a little bit better. If I go over here, I can just start painting in trees. And if I change this value maybe to something like 0.5, I'm going to increase the size of my brush. As I paint, I'm creating a little forest. And, you know, if you had any other types of clones, you could see how you could create sort of a cloner on your own by just working with it this way. So that is sort of one of the benefits of using attributes to control your clones. I'm going to hit D key and go back to the dark background. Yeah. So, yeah, fun. Just painting some trees, you know? So if that's, you know, so if this is what you're after, I mean, obviously this is one way to do it. There's plenty of ways to skin a cat, as in every piece of software, but yeah, definitely check that out. And in the next little chunk I want to check out right here, I want to just do one more thing, which is talk about attribute transfer. So we've talked about, so far we've talked about creating attributes using paint nodes, attribute create nodes, attribute randomize nodes. Well, another way we can create attributes on an object is by having another object that gets close to it. It will sense that it's close to it and then transfer its attributes onto that object. So let's create another grid. And I'm going to do the old trick where we clone a bunch of spheres onto it again. So I'm going to throw it on a sphere. And I'm going to hit copy to points. And I'm going to make the grid, we're going to make it another 50 by 50. And copy the spheres onto the grid. And boom. There you go. They're all overlapping. I'm just going to take my sphere size down a little bit so that it is, you know, about 0.07, something so that they're not like fully overlapping, maybe something like that, you know, just make them a little bit easier to see. So now, what I could do is I could actually create a point and a fall off and say anything that's close to this point, I want you to influence the scale of this sphere. So let's do that. Let's create an attribute for P scale. So I'm throwing down an attribute create, wiring it in here. I'm setting this to P scale. And because it's set to 0, all of our spheres shrink and disappear to nothing. Cool. And then I can throw down a point, an add sop like we did earlier. This add, I'm going to just turn on its position. So you can see we've got a position at the origin. And I'm going to option drag this attribute create over and wire it into the add. And I'm going to give this P scale a value of 1. So both of the grid and the point have attributes. They have a P scale attribute, which you can see here. Now, the P scale attribute on the grid by default is set to 0, but on the point it is set to 1. So if I use the attribute transfer node, very powerful node, we use it a lot in this course. If I throw this down and wire in, let's look at these inputs. The first geometry is expecting geometry to transfer attributes onto, so that would be our grid. And then over here, it's looking for geometry to transfer attributes from, which would be our point. So if I highlight this, and then we're going to wire this into our copy to points now. And then highlight our copy to points, you see all the spheres get big. And that's because by default, attribute transfer is transferring everything. And it's got a wide radius that it's using. So I'm just going to untick primitives because we're really concerned with the point class that we created here, point. So if I go and I select from the dropdown, I want to transfer P scale just to make it explicit. We could be transferring a whole bunch of stuff. We could be transferring color, temperature, all sorts of attributes if we had them, but really we're only concerned with P scale. And I'm just going to switch over to the conditions tab here, and I want to take this distance threshold down. And as I drag that down, you can see the sphere starting to shrink. It's because this distance threshold represents a hard edge where the attribute is going to either be 1 or it's going to be 0. So if I bring this distance threshold all the way down to 0, then it is transferring the attribute of 1 from this P scale, a distance, it can only reach a distance of 0 around that point. But if I go back here and turn on the, let's just highlight the copy to points. If I go back to the attribute transfer and start cranking up the blend width, you can see that we get this nice sort of fall off effect. So now if I were to go grab this, add a node where this point was and drag it around, you can see it's changing the scale of those points based off of where my input geometry is. And I could change this to be any shape. If I wanted to create a fall off in the shape of a torus, I could do that. If I wire in my torus, and let's just to make it easier to see, we'll just increase the radius of the torus on the, we'll increase sort of the I increased the outer radius, but then the inner radius, the second parameter, I made a little bit smaller. I'm going to just increase its overall size. But then now if I go over here to copy to points, and I'm just going to bring the blend width down to make it a little bit more obvious, you can see that each point of the torus is falling off and creating this sort of, if I highlight this, you can see all of these points where they get close are starting to create this fall off for that attribute transfer. If I just increase that blend width, you can see that it's starting to create that pattern that we're after. So now if I were to go and move my torus around, it would sort of act as a mask for modifying this attribute on this stream. So I know that this overview of attributes may have been a little bit overwhelming. I know that there's a lot of information there. If it didn't quite fully stick initially, hopefully as we explore more over the next, several lessons, that it will start to make more sense, to see it in context, to see it in action. And if it doesn't, click right away. You can always come back and watch this lesson after you've gotten some more context about how it works in the greater system in Houdini. We're going to be using it throughout the rest of this course. We're going to be using it. We're going to be using attributes to drive our simulations. We're going to be using them to do procedural models, all sorts of stuff like that. And so, really just hang in there and know that eventually this stuff is going to start to stick. So that wraps us up for the intro to attributes section. In the next section, what we're going to do is we're going to be looking at VOP networks or VEX operators, and it allows us to have more of like a point level control over our attributes and kind of really start treating them more like shaders and building things in a way that is similar to a shader network. The nodes are organized in a way that might remind you of something more like Espresso or how you would build shaders in Octane or Redshift. So stay tuned for that, and we're going to check out some VOPs next.